Welcome to part 2 of the MVP first-person shooter series. This is the basic setup section. We're going to be covering the basic folder structure for our game to try to keep it organized, and we'll also get started on creating the basic classes we're going to need, and then disabling one very annoying feature. So let's get right to it. So I've gone ahead, I'm using Unreal Engine version 4.10. Any version roughly around 4.10, either plus or minus 1 or 2, should be fine because we're not really going to be doing anything engine version specific. Once you open up the Unreal Engine version, you can go to the new project. We're going to create a blank project. We will not be using the starter content. Feel free to include it if you'd like to. Maybe you want to customize it. You can always import this later. We're just going to go ahead and use the defaults without starter content. I'm going to go ahead and name this project MVP-FPS, assuming I can actually type. Let's try this again. There we go. And we'll go ahead and create a new project. Now that's going to go ahead and run. It's going to go ahead and start up a new project for us. And once it's loaded, we'll have our blank project. Now this video is not intended to show you the basics of blueprints. If you are brand new, please view the Unreal Engine YouTube Beginner Blueprint series. This is intended to be used by people who have the basic knowledge of Unreal Engine, can navigate, and will be able to use blueprints to create a basic first-person shooter. So, first thing we're going to want to do is disable one of the very annoying features. If we go up to the Editor Preferences, Miscellaneous, the option Enable Editor Sounds will be enabled by default. Let's go ahead and uncheck that and close this down. That's the sound that when you start or stop the playing editor makes a bing or bong or ching sound and is really annoying. So now that we've gone ahead and disabled that, let's go ahead and move on to the next section. So, first things first, let's keep this thing organized. Let's go ahead and create a few basic folders that are going to cover how we're going to set up our content. So, we know we're going to have some blueprints, so let's go ahead and do some blueprints. And then in addition to blueprints, we are going to have a character that we're going to control. Let's go ahead and put him in his own folder. And we're going to need a folder for the maps, even though we only have one, because maps have to go somewhere. And that's going to go ahead and cover it for now. We need a game mode, a character blueprint, and a player controller. These are going to be our three basic things that are required to get some form of locomotion and get our first-person shooter character moving. So let's go ahead and start with the first one. Let's go ahead and do a game mode. If we open up in our content browser to blueprint class, you'll find one of our defaults is game mode. If we go ahead and create game mode, and let's name it FPS game mode, this is going to go ahead and create a brand new game mode for us. Now if we open up our game mode, we're going to go ahead and see the defaults. And if we go to our class settings, defaults, we can see our defaults right here. This is what controls our pawn that we'll be using and our controller for our pawn. So that's why we want to create our game mode first, so that way we can set up our custom pawn and our custom controller. Let's go ahead and do that now. So since these will be part of the character, let's go ahead and add them in the character folder. Let's go with first thing first, let's create our pawn. Now, there is a pawn option, but there's also a character option. They are different. An actor is going to be your basic blueprint. It's going to be your base class. In addition to an actor, we get the pawn. It's a subclass or a child of actor, and it adds a few more helpful things. It's useful if you need to possess it by a player or AI, but it doesn't come with built-in character functions. If we create the character blueprint, we're going to get some extra things. We're going to get a collision. We're going to get a character movement component that allows us to very easily control our character, our pawn. Let's go and do character, and we'll name this FPS character. Now in addition to that, we needed a controller. Let's do the same thing. Go to blueprint class, and we'll do a player controller. We'll name this one FPS controller. And there we go. We've created our three basics. Obviously nothing's working yet, but we've got our basics. Now if we were to go ahead and run our example, you'll actually find you can move, but you're going to find you don't follow the normal first-person shooter characteristics of actually being physically there. If you notice, we can fly. We don't really have a gravity, we're not really held by anything, we can just simply fly around. The reason for that is, if you don't have a default character, it's going to go ahead and use the default character that comes with the engine, which is our default pawn. You're also going to notice the default spectator class called spectator pawn. Since these are pawns, they're not going to have physical characteristics, they're not going to be held down by gravity, they're not going to have the ability to do things like jump or have a walking speed, and they're just going to allow you to free fly through the scene. So that's why we need to create our custom character and controller. Let's go ahead and save everything by doing a file save all, because saving everything is smart. At this point in time, if it were to crash, we'd lose all of our work, and that's kind of annoying. So let's go ahead and set up our input so we can move with our WASD keys. We're going to assume WASD for moving, and we're going to assume the mouse for looking. As I go through this, you can obviously customize that to be the keyboard if you'd like. You could be adventurous and try setting up the gamepad if you'd like, or maybe if you're on a different keyboard set than a normal QWERTY, you can obviously change it to the type you'd like. So, in order to set up the keys, we have to use the input settings. Those are found under Edit, Project Settings, and we go down to the Input section. Now by default, you're going to notice nothing is set up. We have two different sections here at the top under Bindings: Action Bindings and Axis Mappings. They're similar. They will both allow us, if we were to click the plus, to assign a name and to assign a key. But the difference is in this section part here. Action mappings are a on-off or a toggle. It's meant for an action, such as jump. If jump was an action, it would be on or off. Either I push the spacebar and jump fired, or I let go of spacebar and maybe we do something else. Axis mappings are basically from -1 to +1 normally, along an axis, either X left and right, or Y maybe up and down, or maybe Z forward and backwards. You have, normally it's just the XY, and you have a scalar here instead of the extra options. Since we're using character movement, which is part of our character, we're going to go ahead and use the axis mappings. We're going to use forward and back, and left and right, but technically we're only going to use forward and right, and you'll see why in a second. So let's go ahead and set up this. Let's go ahead and name this to forward. Let's name this actually move forward, if we can hit the keyboard correctly. And we're going to go ahead and set this up with a scale of 1, and let's set this up to W for our key. That will be moving forward. Now let's go ahead and set up another axis, and we'll call this one move right. And we're going to go ahead and set this one to our D key, because right will be D, assuming I can hit D, not delete. Okay, so now we have a move forward W and a move right D. Now you might be asking, well, what about A and S for left and down, or left and backwards? Well, like I said, axes are forward and backward. Axes have a positive and a negative. So if we were to get a negative here, we're going to find that S is going to be our backwards. And if we're going to get a negative on this one, we're going to find that A is going to be backwards. So what we need to do and set up here is going to be our backwards mappings for A and S. So since W is positive, we want to set up another one for S as negative. And then the same thing here. We're going to go with A, and A, I guess would be more appropriate. And we're going to do this as a -1 as well. And there we go. So what we've done here is now, if we get a W key pushed down, we're going to give a +1 value. And if we get the S key pushed down, we're going to get a -1 value. Now the reason why this is useful to do it like this is if we were to add in gamepad support, then it's easy enough to do forward on the gamepad is 1, backwards on the gamepad is -1, and then you can map these things very simply with just forward and right, rather than forward, backwards, left, and right, and then having to do some math. You'll see why in a second. So this is our basic movement keys. So now that our input's set up, we need to actually be able to do something with our input. And those are creating our events. Now you have two ways of creating your events for movement. You can put it inside your character, or you can put it inside your controller. Technically, you can put it anywhere you want, if we want to be honest. You could get a reference to your character from your alien spaceship, which is in a completely different area, and you can have it control it. But for our purposes, we're going to use the idea of the controller controlling the character. So we're going to put all of our movement logic in our controller. Let's go ahead and do that. Open up our controller, and you'll find by default it doesn't really have anything. It's got the controller with the transform component, but we don't care about this. We care about the event graph. Let's go ahead and delete everything out of here, and let's go ahead and set up our controller. So if we pull open the controller itself, we're going to find nothing. We're going to need to set up our controls for movement. So how do we go about doing that? Well, like I said earlier, we had our input axis for forward, and we have our input axis for moving left and right. So let's actually pull those up. Let's type in forward. And we're going to find axis event move forward. You'll also notice axis value move forward. Well, let's pull both of these in and see what they do. And you notice one is what we want for what we're using, and the other is not. So move forward, this version, which is if we look at here, is going to be our axis value. This is just going to give us the 1 or the -1 or the variation between if we're using like a gamepad and tell us where it actually is. We don't want that because we want to actually know if the person pushed forward or backwards. That's what this is for. This is an event that fires, as you can see here, once per frame, and will tell us the value of our axis. So what we want to do here is basically whenever the person is moving forward, we're going to have a value on the axis of 1 or -1, depending on W or S being pushed, and we're going to move the character. Now remember when I said we wanted to make this a character? Well, if we pull up the character itself and we look over here, we're going to find some things. You're going to find these as inherited. This is inherited from the character parent class. And the important one here is our character movement. If you look over here, there's a ton of options. All of these are given to us for free because we created a character. We get a capsule component for movement purposes. It gives us an arrow so we can see what's forward. A mesh that we can assign if we have a mesh we want, like maybe it's a first person and we have some hands. Or maybe this is a third person and it's our actual skeletal mesh. And then character movement, which actually allows us to easily set speed when we're walking, the ability to jump, how high we want to jump, if it's affected by gravity, basically everything you want in order to control this character moving. Plus it gives us some convenience functions that allow us to very easily move. Actually, it's just one node. So if we go over here and we type in movement and spell it properly, we're going to find in here somewhere. Actually, we need to try that again, sorry. We need to get the pawn, and then we type in movement. This is one of those things that, because of context sensitivity, is a pain to find. So, we have the add movement input node, which is targeted the controlled pawn. Now remember I said there's more than one way you can put this inside the pawn or the controller? Well, the pawn and the controller are meant to go together, and they're meant to work together, and they're meant to synchronize back and forth, so they have convenience functions back and forth. So in the controller, for example, if we were to do get controlled pawn, it'll automatically give us the pawn that's controlled. We don't have to guess. It has a reference to it. In our character, for example, if we were to do controller, you would see get controller, and this will return the controller that we're using for this pawn. So it's an easy way to get a connection between the two of them. In our case, we want the controlled pawn. Now, before I hook this up, let me show you what happens when we set up our game mode to use our new settings. We go to our project, we go to our blueprint, we go to our game mode. We now have a character we want to control, and we now have a controller we want to use. Remember before I could move and fly around and do all that stuff? Well, we're going to break that, and then we'll fix it. Let's change my default pawn to my FPS character. And let's change my player controller to my FPS controller. Now whenever a new player is spawned in the game, it's going to spawn it as an FPS character, and it's going to use the FPS controller to control it. Now if we run, you'll see this. And actually you won't. And why is that? Well, if we look over here, we see default pawn and we see player controller. But in here, we told it to use our FPS character and our FPS controller. So why is it not working? Well, it's pretty simple. Even though we've done this, we haven't actually told the game, our project, to use the new game mode. That's pretty simple. There's two ways of doing it. First of all, you can change the settings in your map, which is under World Settings, which you can get to under Edit, World Settings, or I've got it docked over here, and you have the Game Mode Override. Keep that in mind. It says Game Mode Override, not the default, and this is important. This will override the default game mode to whatever you want. So if we were to do Game Mode Override, FPS Game Mode, and we hit play, now you'll notice, well, you may not be able to because you can't see it, but I'm not moving. I'm not able to move. And if we look over here, we'll now see FPS character and FPS controller and FPS game mode. Since our project is going to use the same game mode for everything, there's another way of doing this. Let's reset this back to default, and let's find actually where the game mode is set. The game mode is set inside of our project settings. So under project settings, we go to Maps and Modes, and you'll find Default Game Mode. Let's go ahead and change this over to FPS Game Mode, and now we'll be using the new game mode. While we're here, we might as well change the new default map to the one we're working on right now. But you'll notice a problem. It's not here. Even though we're in the default map, even though we did save all, we didn't actually save our map yet because we didn't edit the map. Once you make a change to your map, now we can save our map. Let's go ahead and change this to FPS map. And if we go to maps, we now have our map. We can go back to our project settings. We can close down our project settings to refresh it, maps and modes. And we now have FPS map and FPS map. Now we've gone ahead and set up our maps and modes to load our new map and to use our game mode as the default. Now if we were to go in and hit play, you'll find I can't move, and we're using our FPS settings. Okay, well, so far we've got the basics set up, but we still can't actually do anything. So we need to go ahead and fix that. So we need to be able to move, and we were in the process of setting that up. Inside of our controller, we have our add movement input. Well, this is pretty simple. We hook this up into here. We hook up our axis value into our scale value. And this is basically going to say, add movement input to our pawn, and we have it set up here for a controlled pawn, in this direction, using this value. And this is why it was important to set up that plus and minus version of the move forward. So if our direction, let's say, is in our forward direction, and we push the forward key, it's going to take the forward direction, scaled by 1, and it's going to go forward. And of course, if we press backwards on the keyboard, it's going to scale it negatively, and it's actually going to make us go backwards. So with this one node, setting up this one input, we can now move forward or backwards. But as you may have noticed, we haven't filled in our world direction yet. Well, somehow we need to be able to know which way is forward. Let's go ahead and clean up our node a little bit here, just so it's not as annoying. Move this over here, and we'll do a little bit of cleanup. There we go. And let's go like that. Okay, so we need to get our world direction. Well, since we're doing a first-person character, this should be pretty simple. Basically, which way is forward on the character. Well, you can do some fancy math, and you could figure out which way is the forward vector from your model or your mesh. Or we could use another built-in convenience. We have the rotation of the controller. Since we're using character movement, we have a controller rotation convenience function. If we do controller rotation, control rotations. Let's actually spell that properly. Get control rotation. The target is the controller, which is where we are now, and this will give us a rotator, the rotational value of the controller currently. If we figure out from the rotation which way is forward, then we'll know which way is forward, and we'll know when we go forward and backwards, which way is forward and backwards. Let's go ahead and just get the forward vector. Getting the forward vector is basically saying, hey, rotation, which way is forward? And it goes, yo, this way is forward. And then we get a vector. Our world direction conveniently is a vector. Once we clean it up, we now have a world direction that should be forward in the way we are controlling. Let's hit play and find out. If I'm to use W and S now, you notice I can go forward and backwards. That's it. It's as simple as that. We've gone ahead and set up forward and backwards just by doing these few little nodes. Hopefully, it should be pretty simple to figure out what we're going to do for left and right. So let's go and get our move right event, and let's basically set it up the same way. We can actually copy these two nodes, paste them down here. Let's go ahead and hook our axis value up. Give it a little bit of cleanup here. And now we need we need a world direction for left and right. Well, we did this right here. Get control and get forward. You'd think maybe there was an easy way to get left and right. Well, there is. By most of the time when you're doing the 3D math and you're trying to figure out vectors and rotations and character movement or movement in general, you will try to only use two things because the opposite of those two will be the opposite in terms of directions. So if you have a forward vector, doing it by the negative will give you the backwards vector. The reason we did move right is we have a right vector. And of course, the opposite of our right vector is going to be left. So if we set this up, we now have a right vector and a left vector when it's multiplied by our negative axis. Let's go ahead and run this. And you'll notice I can now move left, right, forward, and backwards. My mouse does nothing because we haven't hooked it up yet, but we can actually move. So we might want to actually look. So let's go ahead and set up our look events. So what we're going to do with the look events is pretty much the same thing we just did with our movement events, except they're going to be for the mouse look. So what did we do? Well, first thing we did is made sure we could actually track the movement of the mouse. So if we go back to our project settings and we go to our input, let's go ahead and set up an axis for the mouse. Now we did right and forward for the keyboard, so what do you think we'll do for the mouse? Let's add in two of them and let's set them up. This is pretty simple. We're going to do look up and we're going to do turn. We're going to try to do turn, assuming, there we go, I can type it in. Now this is one of those things where the plus and minus is going to automatically be added because our mouse has a plus and minus depending on which direction it's going. So if we do mouse Y, which is our vertical, and we do mouse X, this is going to automatically apply a scale in the positive or negative based on if we're looking to the right or the left. So we can go ahead and keep these by default here, and we now have a look up and a turn. We go back into our controller, and let's set up our mouse look. Now, the mouse look is really, really simple. Like I said, we had our movement input convenience function. Well, we probably have mouse convenience functions. So let's set up our look up, axis event, not the axis value, and set up our turn and make sure it's the axis event. Now you'll actually might have noticed something if you were paying attention. When I typed in turn, it actually pulled up something that doesn't have the word turn in it. And that's a bit weird. It says add yaw input, but if we read the description, it says add yaw turn input. This value is multiplied by input yaw scale. Well, let's go ahead and pull this out and let's figure this out. Well, like I said, there was a convenience function for adding movement. There's also a convenience function for adding mouse looking. Remember how we have the control rotation? This allows us to set it up very, very simply. Well, how simple? We just hook these up. That's it. If I were to run this now, we're going to find I can now look left and right by moving my mouse left and right, and I can actually move forward, backwards, left and right on the keyboard. So now I've got all my controls working except for looking up and down. Well, hopefully that should be easy to figure out. If we go back into here, we need another event for looking up and down. So if we drag off, let's see, we had add yaw input. Let's go with add input. Let's see what else we have. We have the pitch and the roll. Conveniently, they were nice enough to tell us which one to use. Add pitch or look up is for looking up. Let's set up add pitch, hook it up, and hit play again. Now I can look left and right, move forward and backwards, and I can look up and down. But there's a slight issue. When I'm looking up and down, if I move the mouse up, it's actually looking down. And if I move the mouse down, it's looking up. It's an inverted y-axis. Some people like this, some people don't. Most games will give you an option to toggle it. For our purposes, I'm going to go ahead and set this to the default looking up by pushing up or forward on the mouse. There's a few ways to do it. One of the extra side projects will be to allow a toggle, but for our purpose, we're going to do this very simple. The axis value determines if it's looking up or down. Now remember I told you it's positive or negative based on if you're moving the mouse up or down, forward or backwards. So all we need to do is go into our project settings, our lookup, and we'll actually reverse our scale. This is going to reverse it on the input, which means the actual controller will take in a inverted input. We hit play. Now I can look up, down, left, right, backwards, forwards, left and right. Despite the fact it's taken us about 20 minutes, we've gone through and we actually have a fully working first-person shooter controller input from scratch. And you've seen that all of this was allowed because we have some nice convenience functions. Now there is a small issue that we're going to run into. When I am moving around like this, I don't have an issue. But if I was to look down and now try to move, I can move left and right, but I can't move forward and backwards. If I was to slowly look up, I would be able to slowly move. Now the problem here is we are getting the control rotation on our controller here. The problem with the control rotation is it is getting the X, Y, and Z on the rotation, and unfortunately the X and the Y are causing us to not be able to look when we are move when we're looking down. So we basically need to strip out everything from our control rotation except for the Z. That's our up and down axis or our rotational axis. So that way we're not going to be affected by if we're actually looking up or down when we want to move. Well, this one's pretty simple. There's two ways of doing it. We'll cover both. Inside of our control rotation, if we break the rotation, which it says right here, break rotator, not break rotator into axes. If we do break rotator into axes, we're going to get 3 axes per axis. What we want is the actual rotation per axis, which is break rotator, which is going to give us our X, Y, and Z. We move our vector over here. We do a make rotator. And what this is going to do is allow us to only hook up the Z, pass in 0 and 0 for the X and Y, and then pass that in to our get forward vector. Now keep in mind this is for our movement input for the forward axis. So if I go ahead and hit play, and I look down, I can now move again properly without any issue. Now the other way of doing this, because the control rotation is the output right here, is a rotator, which is a structure which can hold other variables, we can actually do it without these nodes. Let's go ahead and see that. This is simple. Right click, split the struct pin, right click, split the struct pin, and we just hook up just the one we want. That's it. Simple as that. Because it is itself a combination, a rotator is a combination of an XYZ float, it's a structure, we can actually split the structure pin. Now, if you noticed, I had to disconnect it. If I was to try to right click and split, it'll be grayed out. Because we already have something assigned here, you cannot split. You can only split when you have no connection. So, there we go. So now, we go ahead, we hit play. We can move, we can look up and down. Looking up, we can look around. Looking down, we can look around. And actually, if I was to look up to show that it is working, I've fallen off the platform and will continue indefinitely. So that is it. That is going to wrap up the first video. That is our basic setup. We've created our basic structure. We have created our basic first-person controller movement. We can look around and use our mouse. We've gone ahead and fixed 2 small bugs.